you have 3 to the power of 2x minus 1 is equal to 27 to the power of x minus 2. Okay? Right? This is 2x plus 1 is the plus 1. Yes?
So this way you have to try to get 27 to the 3 and then the rest will work.
You have to convert that 27 to a base of 3 first. So this becomes 3 to the power of 2x plus 1, that's equal to 3 to the power of 3, all raised to the power of x minus 2. Okay? Then you need to remove brackets there. So we get 3 to the power of 2x plus 1 equal to 3 to the power of 3x minus 6.
So what is this?
I have to check that, but it's exercise 3. And I exponential equations. Now that the base is the same, it means we can say therefore the exponents are equal. Equal to 3x minus 6. Okay? It becomes a grade 9 equation. Grade 8, grade 9 equation. So to simplify here, yes. Yes. I don't want to say cancel. The 3 disappears because we are saying if the bases are the same, if their exponents are equivalent.
So the base doesn't need to be
Yeah, the base doesn't need to be.
It's not to the power of 1 something.
Right. Then 2x minus 3x will be equal to minus 6 minus 1. This will give you minus x. That will give you minus 7. Okay? Yes?
So why is it the other way around?
No, I took this 3x to the left.
You said if you took the 3x to the other side instead.
It's the same thing. Okay. It's fine. You can do it that way. Can you look whilst I'm simplifying? I'll come to the answer to that. Actually, we get check this 2x the other side, check the minus 6 the other side. So here we divide by the coefficient of x, which is what? Minus 1. Then you divide by minus 1, you get x equal to 7. So if you have taken this 2 to the right, you get 3x minus 2x, which is what? X. Then you take minus 6 to the left, it becomes 1 plus 6, which gives you what? 7. So you still get the same answer. But you can decide the way you prefer. Okay? Sometimes I do it the way because that's what we just spoke about. Okay? So this is very simple. This is grade 10 actually. Okay, so let's move on to, okay, all of the questions. Okay, let me do number 6 with a rational exponent, with a rational base. So that's a half raised to the power of x minus 5. Okay, so I'm going to go to the next page. So number 6, we have a half raised to the power of x minus 5 is equal to 64. Right? By now, all of you must know that a half can be written as 2 to the power of minus 1. You should know this. And 64 is the same as 2 to the power of 6. Okay? Without using a calculator, you should know that. Then this becomes 2 to the power of minus x plus 5 is equal to 2 to the power of 6. The base is the same, therefore the exponents are equal. So minus x plus 5 equal to 6. Okay? I can take the minus x to the right, take the 6 to the left. Okay? So I can have 11, sorry, not 11, it would be minus 1 is equal to x. So x is going to be minus 1. Alright? Now let me do the last example for the day. Now, This is now where grade 11 starts, exponential equations. Now, your knowledge of factorization is required to do these problems. Okay, and I've already spoken about it when we were simplifying exponential expressions. So I'm going to choose one question that I'll do, and you can choose for me which one you want me to do.
4.
1,
6.
Huh?
4,
I'll do number 4.
9.
Okay, number 4, you have 5 to the power of x plus 1 minus 3 over 25 is equal to 2 times 5 to the power of x. Okay? That's the question. Now, this question here, we can approach it in many ways, more than one way, right? But because of my time, let me do it this way. First thing, I'm going to take the minus 3 over 25 to the right. Okay? And remember, the objective is to solve for x, determine the value of x. So I'll take the term without x to the right. Then the 2 times 5 to the power of x, I'll take it to the what? To the left. So I'll end up having 5 to the power of x plus 1 minus 2 times 5 to the power of x is equal to 3 over 25. Then, on the left-hand side, I need to create a common factor. So the first term, I have to split it using the first law. By now, you should know that we can write this as 5 to the power of x times 5 to the power of 1 minus 2 times 5 to the power of x equal to 3 over 25. Okay? Then we take out a common what? Common factor, which is 5 to the power of x. So you get 5 minus 2 equal to 3 over 25. So this will give me 5 to the power of x times 3 is equal to 3 over 25. Okay? Then, there is also more than one way of carrying on from here. The 25, I can write it using a base of 5. So I can write this as 5 power of x times 3 is equal to 3 over 5 squared. You see that? I can also divide both sides by this 3. It's another way too. Right? But because of time, I don't have the time to show you all of them, but I'll show you this one. So the next thing that I'm going to do now is convert this, take this 5 squared, I can take it to the top, becomes the numerator, and the exponent changes from being positive to what? Negative, using definition number 3. Remember, definition number 3, x to the power of minus n is equal to x to the power of n. Now here we move from the right towards the what? The left. So if we do that, I can start by writing 3 first, raised to the power of 5. So what I'm doing here is, instead of starting with 5 to the power of x, I'm starting with 3. Because there is what? Multiplication. You can swap the two. Right? You can only do that when there is what? Multiplication. Then this, I can write it as 3 times 5 to the power of minus 2. Then these two are going to cancel out. They are cancelling out because they are part of monomials on both sides. And there is multiplication. Okay? So we end up having 5 to the power of x is equal to 5 to the power of minus 2. Therefore, x is going to be negative 2. And then we are done. Right?